everyone. Today I will be showcasing this compact, programmable combination lock. Its dimensions are up here. It's 9 by 22 by 7. This does not include this torch, since it can be placed anywhere along these blocks as long as it reverses the signal from this line. And of course it does not include these black lines, as these can vary in length depending on where you want your output signal to go. If you want to hook it up to a large redstone contraption a million miles away, you can do that. And that's why I don't count that in the dimensions. So right here, as you can see, we have a couple of modules here, I believe. We have 1, 2, 3, 4. This is the programming. Then this is the main signal line, which just reverses this up here. I'll just be showing how it works right now. So this is a programming strip up here. Now when levers are flicked up, pointing towards the sign, these are the actual buttons, corresponding buttons on the 9-digit keypad over there that you have to press. As you can see, this reverses both pistons over there. So by flipping up 1, 2, and 3, it does not matter what order you press this in, because indeed this is a combination lock. Press 1, 2, and 3. You'll see that our redstone lamp has lit up. This is just your output signal. Just remember, when this is on, that means it is solved. And this is your reset signal, which will close the signal and reset all these lines back here. This is very simple. Reset line, just basically when these torches turns on, it makes sure all these torches up here will be turned off. Now if you can see back here, this is how it works. So I'm just going to use number 2 for example. As you can see, this redstone torch is unlit. This just flips the signal back here. So when this torch is unpowered, this torch becomes powered, because now it doesn't have any signal telling it not to be unpowered. Because right now, the only thing that is keeping this torch off is this torch down here, which when this torch is on, it'll make sure that this torch stays off until this torch turns off. So when it's on, it transmits a signal over here, which this torch is normally off. If this block was above it, which we can flip, so if that was the wrong button to press, I'd flip it like that. So 2 is not the correct button, so if I press 2, what happens is it actually gives power to the reset line. This reset line will reset the circuits and basically voiding any numbers that you pressed before then that were right. And down here, since I have block on like this, since this block is transmitting a signal to here, we have to reverse that signal by turning this torch off to get this torch up here to turn off. Once all these torches up on this top row are turned off, this whole redstone line will be turned off, making this torch turn on. That's how it works. So by pressing number 2, you can see that this torch turns on, this torch turns off, this torch turns on, but it will not reset because that piston is not down. This will turn off this entire line, which will turn off this torch. Now by pressing all the correct buttons, this entire line will come off, making the output signal output. Back here is the reset line. I wired it around this torch, soft powering this block, and then taking that signal from that block with the repeater. The reason I had to soft power it, because if you hard power this block with the repeater, what happens is you will actually power this block with the repeater once you press it, and you don't really want any other redstone signals to go through the system when you're trying to reset it, because you can glitch up the system. It basically just keeps on like putting a redstone clock output basically. And you don't want that. And this button, it just wraps around here, making sure I'm not touching any redstone. It just wraps up here. That's basically it. It basically uses the same mechanics as you would with your lever and torch, your basic redstone signal line. So if I demonstrate that here, you have like a couple of torches and you have redstone dust going to the ones that you want not to be flicked down. So as you can see, this machine goes off that basic mechanics except all the torches in the back. There's all torches on the back. There's no redstone dust in the back. As you can see, all these blocks are torches. There's no redstone dust going up to the levers. See, if you flick along lever here, you will not get the output signal. Flick it right, you will get an output signal. It goes off that basic principle, but except I have all the torches back here, and I have changed behind the torches. I've just put a system that tells it which torches need to be flicked or not on the buttons. That's basically how the system works. So the only torches that actually need a signal into it are these two torches. I just did that with pistons, a much bigger design for this combination lock. This is as compact as I could find, get it to. I have no idea how to make it smaller. If you find out how to make it smaller,